All right, when you've reached this point in the packet, I'm here to show you how to see if an ordered pair or a point is a solution to a system. So when we zoom into number 1, what we're going to be determining is whether this point, 1, 5, is actually on both the first line, which is negative 5m plus 6n equals 25, and whether it's also on the second line. If it's on both of those lines, then that means that is the point where they intersect, and it is the solution to that system of equations. So what you'll notice first of all is that the letters here are m and n instead of what you're used to, which is x and y, right? So what you've got to do is kind of think about that alphabetical order. M comes before N in the alphabet, just like X comes before Y. So I'm going to go through and I'm going to start renaming everything the way that I'm more comfortable. So I am more comfortable with X and Y in my coordinate pairs. So that means I'm going to go through and every M I'm going to make into an X and every N I'm going to make into a Y. So you kind of have to follow alphabetical order. X comes before Y, M becomes the X because it comes before N, which is the Y. Okay, so now I've got these two equations. What I've got to do is do some substitution. If this is my X value, right, my pink, that means that it should work here and here, and my Y value, 5, should work in the place here and here to make two true math sentences. So I'm going to start with the first one. I'm going to rewrite this negative 5 parentheses, that's where I'm going to place my X value, plus 6, there goes my Y value, equals 25. So my X value that I'm using from my point that I'm testing out is 1. So everywhere I see an X, I'm going to put a 1, and everywhere I see a Y, I'm going to put a 5. So now I basically just have to do PEMDAS and see if it works. Negative 5 times 1 is negative 5. 6 times 5 is 30. And I need to see if negative 5 plus 30 does equal 25, and it does. So that means the point 1, 5 is definitely on this line, the first one. It works for that one. Now I've got to do the same thing with my second one. So I've got to take negative 7, and I'm going to take out my X and replace it with my X value, plus 8 times my Y value, and see if it equals 33. So my X value was 1, my Y value was 5. I've got negative 7 times 1 is negative 7. If I add that to 8 times 5, which is 40, it should equal 33. And it does. So because this dot is on both lines and works for both of these, then we can say it is the solution for this system. My final answer for number 1 is just to say, yes, it works for both. And then all the math above is my evidence.